Hello students, today's subject is household equipment and the topic we are going to cover under that is equipment design and their effect on work and body posture, certification and guarantees. The objectives are 1. To define and classify common household equipment. 2. To explain the factors affecting the selection of common household equipment. 3. Understand the proper use and care of common household equipment. 4. Understand the need and methods of resource conservation. Equipment is defined as the set of articles or physical resources serving to equip a person or thing as the implements used in operation or activity. They are also termed as tools, be they devices, machines, or vehicles which assist a person in achieving an action beyond the normal capabilities of a human. The applied science of equipment design as for the home is intended to maximize productivity by reducing user fatigue and discomfort. Apart from this, the design also has an effect on the work and body posture. Hence, when choosing an equipment for the home, the following guidelines should be considered. Equipment has been in existence since prehistoric times. The transition from the primitive era stone wedges to sophisticatedly engineered equipment has changed the way work is performed today. The advances in equipment also have created new challenges involving the complex interaction between users and their tools. Improper equipment selection has been known to result in injuries, variable quality of work and decreased efficiency and productivity. Posture is the position or carriage of the body in a sitting or standing position. Even a good posture, when held for a long time, can lead to fatigue or discomfort. The position of workstation equipment has to be taken into consideration when initially designing to prevent future problems. The effects of postural discomfort should be considered in the design because a person may be able to tolerate an uncomfortable posture for a limited period of time, but over a long period this will cause problems. Next, we will look at equipment design and their effect on work and body posture. Using the wrong equipment or using the right equipment incorrectly can cause work-related postural changes resulting in musculoskeletal disorders. WMSDs are injuries of the muscles, tendons, joints and nerves that usually manifest over a period of time and can affect a variety of body parts. Risk factors associated with the use of equipment that can increase the risk of WMSDs are awkward wrist or hand postures, static muscle loading, mechanical stress, vibration, noise, torque, temperature and pinch points. Guidelines for appropriate selection and use are available as ergonomic guidelines. Ergonomics is defined as the study of workplace equipment design or how to arrange or design devices, machines or workspace so that people and things interact safely and most efficiently. Ergonomics is also called human factors analysis or human factors engineering. Ergonomic design facilitates harmony between the person and the person's work environment and equipment by addressing individual needs or characteristics and by positioning the body so there is less stress and strain on it while performing required tasks. Failure to pay attention to ergonomic issues can result in a wide array of workspace injuries, some permanently debilitating. Examples of injuries are potential strains and sprains. A poorly designed workstation can result in twists, turns, and uncomfortable movements. Ensure that there is enough desk space to comfortably accommodate the materials and equipment that are part of the job: books, papers, calculators, computers, and printers. Injuries sustained while lifting and stretching. Lifting heavy objects can cause serious injuries, but failing to lift objects of any weight properly can result in injury. Workers need to be taught the proper methods of lifting and stretching, whether it's a service recipient, a carton of books, or furniture. Repetitive injury due to improperly adjusted working heights. Individuals can sustain repetitive injuries by working at computer workstations that are not properly adjusted. Repetitive injuries are particularly chronic problems that could result in permanent disability. For this reason, including ergonomic guidelines in equipment design has received considerable attention in the past few years. Ergonomic design can help optimize human performance by ensuring that the equipment positively supports the task needs as well as the human capacity. Next, we will talk about the guidelines for good equipment design. The following questions can be helpful in selecting equipment of a good and suitable design to avoid postural problems. The following questions can help in selection. Question 1. What will the function be of the tool? What are the specific task requirements like torque magnitude? Question 2. Where will the equipment be used? To determine the work surface orientation. Question 3. Who will be using the tool? For this, we can gather information about the user's gender, anthropometry, etc. The following ergonomic design guidelines for equipment characteristics to reduce ergonomic risk associated with equipment will help. The next topic is ergonomic principles for good posture. The ergonomic principles can be readily applied at work, at home, or any other place to reduce the effect of wrong choice of equipment leading to wrong postures. The first principle is work in neutral postures. Your posture provides a good starting point for evaluating the tasks that you do. The best positions in which to use the equipment and work are those that keep the body in neutral. The principles are: maintain the S-curve of the spine. Your spinal column is shaped more or less like an S. It is important to maintain the natural S-curve of the back when using equipment, whether sitting or standing. The most important part of this S is the lower back, which means that it is good to keep a slight sway back. When standing, putting one foot upon a footrest helps to keep the spinal column in proper alignment. When using equipment for long periods in seating posture with your back in a C curve can place strain on your back. Good lumbar support is often helpful to maintain the curve in the small of your back. The inverted V curve creates an even greater strain on the back. Even without lifting a load, bending over creates a great deal of pressure on the spine. One common improvement is to use a lifter or tilter when using any equipment which requires bending, so that this posture can be avoided. Keep the neck aligned. The neck bones are part of the spinal column and thus are subject to the same requirements of maintaining the S-curve. Prolonged twisted and bent postures of the neck can be as stressful as its equivalent for the lower back. The best way to make changes is to usually adjust equipment so that your neck is in its neutral posture. Keep the elbows at sides. The neutral posture of your arms is to keep your elbows at your sides and your shoulders relaxed. In the right hand illustration, the equipment has been reoriented and the shoulders and elbows drop to their relaxed position. Keep your wrists in neutral. There are several good ways to think about wrist posture. One way is to keep the hand in the same plane as the forearm. A slightly more accurate approach is to keep your hands more or less like they would be when you hold the steering wheel of your car at 10 and 2 o'clock position, slightly in and slightly forward. Below is an example of how this principle applies to tool design. Working continuously with the scissors, pliers as shown in the left hand picture can create a lot of stress on the wrist. By using pliers with an angled grip, however, the wrist stays in its neutral posture. The next topic is ergonomic principles during use. How to reduce excessive force. Excessive force on your joints can create a potential for fatigue and injury. In practical terms, the action is for you to identify specific instances of excessive force and think of ways to make improvements. For example, pulling heavy equipment like vacuum cleaners, washing machine, sewing machines, etc. might create excessive force for your back. To make improvements, it might help you to make sure the floor is in good repair, that they are on casters and that there are good grips. The third principle is to keep everything in easy reach. In many ways, this principle is redundant with posture, but it helps to evaluate a task from this specific perspective. Next topic is the reach envelope. One concept is to think about the reach envelope. This is the semicircle that your arms make as you reach out. Things that you use frequently should ideally be within the reach envelope of your full arm. Things that you use extremely frequently should be within the reach envelope of your forearms. Much of the time, problems with reach are simply matters of rearranging your work area and moving things closer to you. This is not exactly a hard concept to grasp. What is difficult is having the presence of mind to notice and change the location of things that you reach for a lot. The fourth principle is to work at proper heights. Working at the right height is also a way to make things easier. Do most work at elbow height. A good rule of thumb is that any equipment you use should help you do work at elbow height, whether sitting or standing. There are exceptions to this rule, however. Heavier work is often best done lower than elbow height. Precision work or visually intense work is often best done at heights below the elbow. Sometimes you can adjust heights by extending the legs or by putting a work platform on top of the table to raise the work up, or by standing on a platform to raise you up. The fifth principle is reduce excessive motions. The next principle to think about is the number of motions you make throughout a day, whether with your fingers, with your wrists, your arms or your back. One of the simplest ways to reduce manual repetitions is to use power tools whenever possible. Another approach is to change layouts of equipments to eliminate motions. In the example here, the box is moved closer and titled so that you can slide the products in rather than having to pick them up each time. The sixth principle is minimize fatigue and static load. Holding the same position for a period of time is known as static load. It creates fatigue and discomfort and can interfere with work. In the workplace, having to hold parts and equipment continually is an example of static load. Having to hold your arms overhead for a few minutes is another example of static load, this time affecting the shoulders muscles. Sometimes you can change the orientation of the work area to prevent this, or sometimes you can add extenders to the tools. Having to stand for a long time creates a static load on your legs. Simply having a footrest can permit you to reposition your legs and make it easier to stand. The seventh principle is to minimize pressure points. Another thing to watch out for is excessive pressure points, sometimes called contact stress. A good example of this is squeezing hard onto a tool like a pair of scissors. Adding a cushioned grip and contouring the handles to fit your hand makes this problem better. The eighth principle is to provide clearance. Having enough clearance is a concept that is easy to relate to. Work areas where the equipment is to be used needs to be set up so that you have sufficient room for your head, your knees and your feet, so that one will not have to bump into things all the time or have to work in contorted postures or reach because there is no space for your knees or feet. Being able to see is another version of this principle. Equipment should be built and tasks should be set up so that nothing blocks your view. Next, we are going to discuss certification and guarantees. Till now, we have seen how selecting a good design of equipment can affect posture and its use. Another aspect of equipment selection is the certification and guarantee given to the equipment design, which also plays a major role in their selection. The market is flooded with many products and services, but it's hard to identify which one is good or bad. As a buyer, one can specify the product of choice to set a standard for the manufacturing entities. These specifications are called guarantee and warranty, which will safeguard the interest of the consumers. In business parlance, the guarantee is termed as a promise given by the seller that the particular product will be replaced or repaired in case it is below standard or if the design is not suitable. On the other hand, warranty provides assurance that the statements made about the product are true. Next, we will discuss the definition of guarantee. The guarantee is defined as the promise for the after-sales performance of the product or service. It expresses that the manufacturer has given promise regarding the content, quality or performance design of the product, and in case the obligation is not fulfilled, then a manufacturer will replace or repair the product, or the money paid as the consideration will be refunded. Although it is valid up to a fixed time only, guarantee adds to the rights of the consumer. Now we will discuss the definition of warranty. Warranty is defined as an assurance given by the manufacturer or seller to the buyer that the specified facts about the product are true. It is a collateral condition to the main objective of the contract. It specifies that the particular product is up to the standard, that is quality, fitness and performance. It applies to tangible objects like machines, electronic equipment, etc. In case if the product does not satisfy the set standards, then the manufacturer will repair it or replace its defective part or it will be completely replaced. There are two types of warranty, that is express or implied. Now we will discuss the key differences between guarantee and warranty. The main differences between guarantee and warranty are described as below. The first is, the guarantee serves as a promise made by the manufacturer to the buyer, that is, in case the product is below the specified quality, it will be repaired, replaced, or the money deposited will be refunded. Warranty is a written assurance that the facts specified in the product are true and genuine, but if they are not, it will be repaired or replaced. The second difference is, the guarantee is a sort of commitment made by the manufacturer to the purchaser of the goods, whereas warranty is an assurance given to the buyer by the manufacturer of the goods. Guarantees can be oral or written, where oral guarantees are very hard to prove, as opposed to warranty, which is usually written, and so it can be easily proven. The guarantee covers product, service, persons and consumer satisfaction, while warranty covers products only. The guarantee is free of cost. On the other hand, the customer should have to pay for the warranty to safeguard the interest. A guarantee is comparatively less formal than a warranty. The term of the guarantee varies from item to item. Conversely, the warranty is for long term or any product or any part of the product. In case of guarantee, money back is possible. If stated specifically, however, this is not possible in warranty. A warranty is a subsidiary condition of sale, which may be expressed or implied. On the other hand, guarantee may or may not be a condition of sale. The following table gives us a comparison of these two terms. The basis for comparison: guarantee and warranty. Meaning, the guarantee serves as a promise made by the manufacturer to the buyer that in case the product is below quality, it will be repaired, replaced, or the money deposited will be refunded. In warranty, warranty is a written assurance that the facts specified in the product are true and genuine, but if they are not, it will be repaired or replaced. What is it? A guarantee is a commitment. A warranty is an assurance. How is it applicable? A guarantee is applicable to the product, service and persons, whereas a warranty is applicable to the product only. What are the conditions of sale? A warranty may or may not be a condition of sale, whereas a warranty is a subsidiary condition of sale which may be expressed or implied. Now, validity. For a guarantee, it can either be oral or written. For a warranty, it is generally written, so it is easy to prove. The next is cost. A guarantee is free of cost, whereas for a warranty, the buyer has to pay for warranty. The terms are: for warranty, the term varies from item to item, whereas for warranty, it is long term. Money back in case of default. For guarantee, it is yes. For warranty, it is no. This is a method used to determine prospects for equipment modernization and repair in and to ensure the rational use of equipment in the production process. Equipment is usually certified by the manufacturing enterprise, and the certification document or certificate will give a systematic view of the equipment design certification data. In the process of equipment design certification, all the working parameters and control and regulatory systems are checked, and the functions of the given equipment are defined more precisely. The result of equipment certification is the certificate, a technical document that contains information on the basic function and special applications of the equipment design, both of which determine the rational equipment use. The content and scope of the certificate depends on the type of equipment. The certificate includes general information. For example, the certificate of machine equipment includes an operational diagram, a list and the description of control systems and other information. The certificate of special equipment contains detailed information on its maximum productive capacity, while the certificate for general purpose equipment contains information that makes it possible to choose an efficient operating mode and to determine the range of applications of the equipment. Thus, it can be concluded that advances in equipment have created new challenges involving the users and their equipment design. Improper equipment selection results in injuries, variable quality of work, and decreased efficiency and productivity. Equipment design also has an effect on posture. Hence, the position of workstation equipment has to be taken into consideration when initially designing to prevent future problems. The effects of postural discomfort should be considered in the design. So viewers, I hope you found this session extremely useful and resourceful, and in future you will consider these topics. Thank you.